All right, so please record our goal, and this is the apex. This is the end of all days. This is the thing we've been focusing on getting to. Our goal for today is we are going to solve quadratics that have complex solutions. So we are going to use completing the square to do that. And as another example, we're going to do quadratic formula. Remember, sometimes it's easier to do completing the square. Sometimes the only option is quadratic formula. So let's recollect real quick before we go on. How do we know when we were going to expect no real solution? So remember, sometimes we said, oh look, we get no real solution. In what context was that? Well, if we had graphed the function or the corresponding function, like so, and your graph ended up doing this, such that the parabola never intersected the x-axis, your result would be no real solution. And we didn't give up. We just said we don't have the tools to do it. So we said we don't need to go further. That's where we're done. Or in a situation like this, if I said x squared was -4, and then you said, well, I'm going to take the square root of both sides, and you say, oh, hashtag, you can't do that. And in the end, we would say, no real solution because you can't take the square root of a negative, which at the time was true. We didn't have the tools. We didn't have the language. We didn't even have the number system to take the square root of a negative. But then along comes imaginary math people who do imaginary things and came up with it, and now we've got the mad skills to do it. So all today we're going to do is marry the two topics that we've talked about, complex numbers and solving by completing the square or quadratic formula. So in terms of completing the square, the first big thing we need to do is isolate the constant. So I'm going to isolate the constant, and the way I do that is simply by subtracting the 28 from both sides. I'm going to leave myself a little bit of space right there because of the next step. Now we take the b, in this case is 4, we divide by 2, and we square that. So coincidentally, that's 4. Just to show you again what I did, I took the positive 4, I divided it by 2, and then I square that. So that's my missing term. Remember, whatever I do to one side, I have to do to the other as well. So I isolate the constant, but then I also have to add the missing term. Now what's nice is the left side will always, this is the point of completing the square, is the left side will always become a perfect square binomial like so. Again, what do? You take the square root of this to get x, take the square root of this to get x, bring down the plus, which is right there. And over on this side, you simplify to get -24. Now, I'm going to take the square root of both sides. Remember, there are 2 alarm bells that should go off in this case. The first one, beep, 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 beep. Don't forget the plus or minus. And the second one is an old alarm bell that is now being disengaged. Says, oh, wait a tick, I can't take the square root of a negative. And now we say we can, we just have to suck that thing out as an I. That's it. So let me take a moment real quick to ignore the I. So I'm going to bring down the plus or minus, and the I comes out. And I'm just going to, over here on the side, deal with the 24 with the radical. Some of you remember that when you factor something like this, you get 8 times 3, then this can be 2 and 4, and this can be the 2 and 2. Remember, the numbers that come out are the repeat. The numbers that stay in are the numbers that don't have a partner to get you out. So the square root of 24 simplifies to 2 radical 3. Now I am going to bring this over, but remember, I'm going to put the 2 next to the I and the radical 3 after that. The reason we do that is probably so we don't confuse the I as part of the inside the radicand. All right, good. Thanks for that clarification. Let's just double check here. 2 times 2, or excuse me, the square root of 4 is 2. That comes out. But I did forget to multiply this 2 here. So this 2 times 3 is 6. So let me clean that puppy up right here. There we go, all better. Now we're not done because we have one more thing to do. I'm going to bring down the x plus 2 because when you take the square root of a square, the radical and the square annihilate each other. Mutual destruction. And now I subtract 2 from both sides to get this as my final answer. So make sure you check your answer on this one. But our next part here, it turns out that completing the square is much simpler to do, but we're just going to show you that there is an alternative way to work here, and we're going to do the quadratic formula. The quadratic formula, again, is x equals negative b plus or minus radical b squared minus 4ac all over 2a. Now, eyes on deck real quick, because I'm seeing a lot of mistakes on just the basic formula. Number one, the fraction bar, the vinculum, has got to go all the way across everything on the left side, or on the right side. So it's got to go underneath this b. Also, don't extend it to be underneath the x. And one more mistake I often see is some people are forgetting the plus or minus. Or sometimes they don't write it, or they write it at the beginning but drop it later. Whatever it is, it stays the whole time. The only time you get rid of it is when you use it. When you split it into 2 separate problems and add one of them and subtract the other. In this context, we're never actually going to split since we can't combine these to be like terms. All right, so now we just start plugging and playing. So, negative b. The b here is 4 plus or minus 4 squared. The a is 1, and the c is 28. And I make sure to get my radical around all that, all over 2 times a. And now the fun part, we just start simplifying, so let's go ahead and do that. I bring down the negative 4. Inside, we'll always simplify something similar to this, and I get 1, 1, 2 when I multiply out, all over 2. And now here, I get negative 4 plus or minus negative 96, radical all there, all over 2. I'm going to do 2 things right now. I'm going to split this into 2 fractions. At the same time, I'm going to simplify this radical negative 9i. So in doing that, I get negative 4 over 2 plus or minus negative 4i radical 6 all over 2. So the big question, of course, people are asking is, where did this come from? How did I get all this right there? So let me just, on the side, show you where the how I simplified the radical 96. I don't need to deal with the I. You can just put that outside. In fact, you can just do that. Okay, so 96 is 6 and 16. I happen to know that, or 2 and 48, something like that. Now, remember, anything that repeats comes out. Oh, look, a pair of 4s repeat. So the 4 comes out. So the 4 comes out. The I is already out. And what stays in? The 6. Right there. Now our final step is to reduce the fractions where I can. 4 divided by 2 is 2, and I keep the negative in the front. And the same thing applies here. This 4 and this 2 reduce. So I get plus or minus 2i over 6. And there's a small mistake here. This negative was never there to begin with, so I'm just crossing it out because it was a mistake earlier.